I'm Lucas Yonda.
I'm Sam Wells.
I'm Sugrue.
And this is our productivity analysis project. We decided to do our project on Einstein Bagel Bros. It's located in Benham Hall. It serves bagels, coffee, and other general breakfast items. And there's usually about 4 to 5 employees working at a current shift. We chose Einstein's because it's a popular breakfast destination for all Pitt students, including all 3 of us, I think. And they often have long lines and food wait times, which show that the process does have some inefficiencies. But things such as food quality and friendliness of the employees are not an issue there. And we knew that those 2 factors would be out of our control, so it was good to see that we wouldn't have to worry about those and could only worry about improving efficiencies. Come on, Nate.
Observing Einstein's initially, we discovered a few things. First, peak traffic occurs between 9:45 and 10:15 as 9 a.m. classes let out. Secondly, tap-and-go orders create bottlenecks in the operation, but are difficult to track from an observer's standpoint and do not contribute to the long lines because they are electronically ordered. So we chose to neglect them from our report. Finally, beverages made at the drink station are delivered separately from the food order. Here we have a flow process chart for the Einstein's operation. It starts with employee 1 taking the order, gathering the bagels and bringing it to the bagel workstation as the customer checks out at the register with employee 5. Employees 3 and 4 prepare the bagel while employee 2 prepares the drink at the drink station. Calculating the total time from order to food delivery for 20 customers during peak times, we saw that it takes 4.08 minutes for a bagel/food item, 2.47 minutes for a complex beverage, such as a latte or smoothie, 4.44 minutes for a combination of both, and only 0.69 minutes for a simple coffee, because all that's required is the transaction. In order to determine how to speed up the steps of the operation to eliminate long wait times, we conducted a time study to investigate which parts of the operation were causing bottlenecks. As you can see here, each observed time for each step is averaged after the employee's determined performance rating is factored into the time. The calculated normal time of 58.74 seconds for the entire bagel/food process is much shorter in duration than the observed cycle time. This is largely due to bottlenecking at the bagel workstation stemming from high traffic at peak time. However, if you look at the coffee/complex beverage operation, the normal time is 91.58 seconds, longer than the normal time for the bagel operation, but much less of a disparity from the normal time to the cycle time for the coffee. This is because due to less orders for drinks, less bottlenecking occurs. We will explain how to reduce these bottlenecks in our proposed improvements portion of the presentation.
After the time study, we decided we needed to see how well the current system is dealing with the flow of customers into the shop. So over the course of 4 days, as you can see, we counted the number of customers who enter the shop and the number who leave over a 5-minute period. As you can clearly see, the number of people coming in is much greater than the number leaving, which causes the long lines to develop, as we previously discussed. And if you take the average of the data we collected, you'll find that 7.75 customers enter and only 6.25 leave over the 5-minute period that we observed, which means that every 5 minutes, 1.5 people is being added to the line during peak hours. If we could achieve a 24% increase in efficiency, then this would completely stop the line from forming. But if we could even achieve only half this at 12%, it would decrease the rate the line forms to only 0.75 people per 5 minutes, which would make it much more achievable for the shop to handle peak hours without too long of a line forming. Another interesting observation we made during this time was that several people seem to approach the store and turn around and leave once the line gets very long, which means that the shop is directly losing profit in result for these long lines forming. After we conducted the study on the rate of people entering and leaving, we noticed that a large proportion of workers seem to be idle at any given time. So we decided to conduct a work sampling analysis in order to determine the actual proportion of workers who are idle. So as you can see, over the course of several days, we made 60 random observations during peak hours. And this table shows the number of idle workers out of the 5 total workers who are usually on shift during peak hours. So with this data, we constructed a 95% confidence interval on the mean proportion of idle employees in the population. And we used the number of observations as n equals 60. The sample mean, x bar, equals 0.81833. Alpha is 0.05, and the computed z-value is 1.96. And the sample standard deviation is 0.0981. So using this data, we used the regular calculations for confidence interval, and the result was that on average 15.851 to 20.816% of workers are idle at any given time, which is a pretty large proportion and points towards the idea that workers are not properly allocated, and by moving workers around to where they can be constantly working, the efficiency of the shop will increase greatly.
So during our observation periods, we observed several issues with the Einstein's process. The first and most major one being the process through which the employees take orders. So the way it is now is you step up, one employee takes your order, writes it down, and then tears it in two, hands one back to you and hands one back to the kitchen. And then as customer, you step to the side and another employee takes your order and payment at the register. And the need for 2 slips here is just very unnecessary and creates much more time than is needed to take the orders. The second one being that there is a bottleneck at the sandwich making station when there is a high volume of traffic going through Einstein's. And the third being, as we touched upon before, that there are a lot of idle workers per our work sampling analysis. So in order to improve these issues which we observed, the first improvement we would make to this process is combining the employee who takes the order and the person who accepts payment for it. So you would, instead of giving your order to one employee and then paying with another employee, you would go straight to the register, give your order to the employee who would then accept payment for the order as well. And in order to make this process even more efficient, we would like to put in some sort of automated system which would send your order directly back to the system electronically. We understand that there have been other systems similar to this already put in place around university. And the fact that Einstein's does not already have it implies that there might be some sort of constraint or limitation, which means that they would not be able to have it. However, that would make the process much more efficient. And the other proposed improvement we had was to completely alter the sandwich making station. So instead of having 2 employees working side by side, with that there's a lot of worker interference. So in order to change that, we want to put the bagel cutter, toaster, and oven in the middle of the sandwich making station and have 2 employees working independently on either side of this. This way the employees aren't trying to work around each other, and they will have all the ingredients they need right in front of them, so they won't have to reach around the other one or reach up high and above to try to get stuff that's might be a little hard to reach. Any questions?